Hi there. Welcome to our webinar on migration considerations in the AWS Well-Architected review. The primary objective of this webinar is to give people looking to migrate to the cloud some more info about their cloud adoption journey and to talk about how an AWS Well-Architected review can help you ensure that new and existing environments are up to AWS best practice. In the first half of the webinar, we will look at the primary factors to consider before migrating to the cloud to better prepare you for your pre-migration. After that, we move on to the AWS Well-Architected review, a framework that has been specifically designed to ensure that your AWS environment is cost-optimized, efficient, and secure. By participating in a well-architected review, you can find and eliminate any elements of your cloud architecture that don't measure up to best practice. My name is Warwick, and I'm from Silicon Overdrive. Silicon Overdrive is an AWS advanced consulting, channel reseller, and public sector partner. We are also AWS Well-Architected partners and AWS EC2 for Microsoft Windows Service Delivery partners. When it comes to cloud migrations, we see a number of different business drivers. First is increasing business agility. Companies are creating business cases where they believe their workforce can be 30 to 70% more productive and deliver features much faster as a result of migrating their skills and applications to the cloud. Data center consolidation projects are common, especially in companies that have been active with acquisitions or that experienced infrastructure sprawl over the years. Thanks to the advances of the cloud and the fourth industrial revolution, there is also an increase in companies looking to completely reimagine their businesses using modern technology as part of larger digital transformation projects and innovation. And of course, any cost-conscious organization is always looking for ways to improve the bottom line by reducing their costs. Of course, when it comes to migrating to the cloud, there are some potential barriers to consider. Things like existing investments, skeptical stakeholders, upfront expenses, application interdependencies, concerns of downtime during the migration, and a lack of cloud expertise. To overcome any potential barriers, we suggest that you lay a foundation for a successful cloud adoption. The first part of that foundation is to build your business case. Here is where you define business drivers and develop a compelling investment justification. Think about things like achieving a faster time to market, improving overall workforce productivity, and gaining additional transparency into operational costs. The second part is to look at the people and organization. Identify new roles and responsibilities during and after the migration. Consider who in your workforce will fill the identified roles, and estimate how workforce will be impacted by cloud adoption. And always remember that executive leadership and guidance will foster organization-wide buy-in. The next element to look at is the methodical migration process. A little later on, I'm going to discuss the 5-step migration process. Use this process to visualize and plan your cloud adoption from business planning and portfolio evaluation to application design and migration execution to cloud operations. You can forecast the amount of time and effort required to complete each step of the migration process and gain a deeper understanding of how to optimize operations on AWS. And remember, if all of this seems overwhelming, Silicon Overdrive is here to assist you in laying out the foundation for your cloud adoption. Let's take a closer look at each of the 3 prongs for your cloud adoption journey, starting with building a business case for AWS migration. When building a business case, it's important that you take a data-driven rationale for your cloud adoption. Look at cost analysis, where you compare potential AWS run costs with your current operating model, and look at and investigate AWS purchasing and pricing options. Next, look at the cost of change. Factor in the consulting costs of your migration planning, and remember to look at the cost of maintaining your legacy environment until the migration is complete. After that, look at labor productivity. This is where you estimate the reduction in the number of maintenance hours that using AWS managed services will provide, as well as the productivity gains your team will achieve from automation. Lastly, when building the business case, look at the business value. To do this, estimate the expected ROI, taking into account faster deployment times and scalability. You also want to look at the reductions from decommissioned assets. As I mentioned earlier, an engaged leadership team helps make a convincing case for migrating to AWS. So when it comes to people and organization, start at the top and work down. The first step is to form a Cloud Center of Excellence, or a CCOE, to establish operational processes and mobilize the appropriate resources. You should include people from all across business segments in your company, not just your techs. Everyone from HR and sales to accounts and engineers should be involved in your journey to cloud. Next, you want to define the best practices and governance standards, automate discovery, and drive change. CCOE members will develop subject matter expertise as the migration effort evolves, helping to gain buy-in from the entire workforce. One of the tools we use to plan your migration and get the people in your organization ready to migrate to the cloud is the AWS Cloud Adoption Framework, or CAF. The AWS Cloud Adoption Framework Action Plan helps you prepare for the transition to cloud-based IT. The journey begins with your leadership team reviewing the 6CAF perspective. Each perspective is used to create work streams that uncover gaps in your existing skills and processes, which are recorded as inputs. These inputs are the basis for creating an AWS CAF action plan to guide your organization's change management as you journey to the cloud. There are 3 business perspectives and 3 technical perspectives that we're going to look at. First, we have the business perspective, which helps you move from separate strategies for business and IT to a business model that integrates IT strategy. Agile IT strategies are aligned to support your business outcomes, and they can adjust to business needs or technical capabilities as they change. Common roles are your business managers, your finance managers, budget owners, and strategy stakeholders. IT finance addresses your capacity to plan, allocate, and manage the budget for your IT expenses with the use-based cost model of cloud services. IT strategy helps you take advantage of cloud-based IT approach to deliver value and end-user adoption. Benefits realization helps you to measure the benefits of your IT investments using the methods for a cloud-based IT operating model. Business risk management helps you estimate the potential business impact of preventable, strategic, and external risks. The second part of the cloud adoption framework is the people perspective. The people perspective helps human resources, HR, and personnel management prepare their teams for cloud adoption by updating staff skills and organizational processes to include cloud-based competencies. Common roles here are human resources, staffing, and your people managers. Their capabilities are resource management, which helps you understand and forecast new personnel needs for a cloud-based model. Incentive management helps you implement a compensation program that will attract and retain the personnel required to operate a cloud-based IT model. Career management helps you identify, acquire, and retain the skills needed for your cloud migration and ongoing operating model. Training management provides guidance on how to develop or acquire training for your employees so that they can perform their roles in a cloud environment. And organizational change management helps you manage the impact of business, structural, and cultural changes caused by cloud adoption. Next is the governance perspective. The governance perspective integrates IT governance and organizational governance. It provides guidance on identifying and implementing best practices for IT governance and on supporting business processes with technology. Common roles here are your CIO, program managers, project managers, enterprise architects, business analysts, and portfolio managers. Portfolio management provides a mechanism to manage IT based on desired business outcomes. It can help to determine cloud eligibility for workloads when prioritizing which service to move to the cloud. Program and project management helps you manage technology projects using methodologies that take advantage of the agility and cost management benefits inherent to cloud services. Business performance measurement helps you measure the impact of the cloud on business objectives. And license management defines methods to procure, distribute, and manage the licenses needed for IT systems, services, and software. From there, we move on to the three technical perspectives. First is the platform perspective, which helps you design, implement, and optimize the architecture of AWS technology based on business goals and objectives. It helps provide strategic guidance for the design, principles, tools, and policies you will use to define AWS infrastructure. The platform perspective also includes principles and patterns for communicating your target state environment, implementing new solutions on the cloud, and migrating on-premise workloads to the cloud. Common roles are the CTO, IT managers, and solution architects. Systems and solution architecture helps you define and describe the system design and your architectural standards. Compute, network storage, and database provisioning helps you develop new processes for provisioning infrastructure in a cloud environment. Provisioning shifts from an operational focus, aligning supply with demand, to an architectural focus, aligning services with requirements. Application development addresses your ability to support business goals with new or updated applications and helps implement new skills and processes for software development that take advantage of the agility gained by cloud computing. Next is the security perspective, which helps you structure the selection and implementation of controls. Following this guidance can make it easier to identify areas of non-compliance and plan ongoing security initiatives. The roles here are your CISO, your IT security managers, and your IT security analysts. Their capabilities will be identity and access management, or IAM, which helps you integrate AWS into your identity management lifecycle, and sources of authentication and authorization. Detective Controls provides guidance to help identify potential security incidents within your AWS environment. Infrastructure security helps you implement control methodologies necessary to comply with best practices, as well as meet industry or regulatory obligations. Data protection helps you to implement appropriate safeguards that protect your data in transit and at rest. And incident response helps you define and execute a response to your security incidents. The final part of the cloud adoption framework is the operations perspective, which helps you run, use, operate, and recover IT workloads to levels that meet the requirements of your business stakeholders. Insights gained through the operations perspective define your current operating procedures, as well as process changes and training needed for successful cloud adoption. Well-managed IT operations support the operations of the business from planning and sustaining through change and incident management. Common roles are IT operations managers and IT support managers. Their capabilities include service monitoring, which focuses on detecting and responding to IT operations health indicators to meet your service level agreements and operating level agreements. Application Performance Monitoring, or APM, provides you with new approaches for monitoring application performance in a cloud environment to ensure that application health meets defined requirements. Resource Inventory Management helps you manage virtual IT assets to provide services that are both high-performing and cost-efficient. Release Change Management helps your team adopt software development best practices such as automation and continuous integration, continuous delivery, or CI/CD techniques, increasing the pace of your innovations. Reporting and analytics helps you monitor the health of cloud assets and provide insights to help you reach the desired level of performance. Business continuity and disaster recovery helps you implement processes to keep your business running during a catastrophic event. And IT Service Catalog helps you to offer cloud services to the business using a model that can help to improve efficiency of providing IT services as well as the productivity of consuming them. Earlier, I spoke about the 5-phase process for a methodical migration. So once we've completed the CAF, we move on to the planning and migration. The first phase is migration preparation and business planning. Here, we take business objectives into account, along with the age of architecture of your existing applications and their constraints. Engaged leadership, frequent communication, and clarity of purpose are required. Aggressive but realistic goals and timelines make it easier for an entire organization to rally behind the decision to migrate. The second phase is about portfolio discovery and planning. Full portfolio analysis of your environment, complete with a map of interdependencies, as well as migration strategies and priorities, are key elements to building a successful migration plan. Beginning the migration project with less critical and complex applications in your portfolio creates a sound learning opportunity for your migration team. The third and fourth phase deal with application design and migration validation. The focus shifts from the portfolio level to the individual application level, and each application is designed, migrated, and validated. A continuous improvement approach is recommended because the level of project fluidity and success comes down to how well you apply the iterative methodology in these phases. The final phase is a modern operating model. Your cloud operating model is an evergreen set of people, processes, and technologies. This constantly improves as you migrate more applications, optimize new foundation, turn off old systems, and constantly iterate. Building off the expertise developed from previous migration of applications enables you to develop a foundation that leads to a continually improving operating model. When it comes to migration, there are 6 common strategies that people use. The first is a rehost, also known as a lift and shift. This can be automated with tools such as AWS Server Migration Service, although you may prefer to do this manually as you learn to apply your legacy systems to the new cloud platform. Replatform, which is a lift, tinker, and shift. Making a few cloud optimizations in order to achieve some tangible benefit without changing the core architecture of the application. For example, reducing the amount of time spent managing the database instances that are migrated to an Amazon RDS. Repurchase or drop and shop. Move to a newer version or different solution. Likely means your organization is willing to change the existing licensing model it has been using. Fourth is to refactor and re-architect. This is usually driven by a strong business need to add features like scalability or to improve performance that would otherwise be difficult to achieve in the application's existing environment. Basically, this entails overhauling all your legacy applications for optimization once they are on AWS. The fifth strategy is to retain. Only migrate what makes sense for the business, and if there are portions of your IT portfolio you're not ready to migrate, you don't. And the final one is to retire, where you identify IT assets that are no longer useful and can be turned off. Remember that help is available. APN partners like Silicon Overdrive, AWS Professional Services, and solutions available on the AWS Marketplace can help determine your migration strategy and develop a contingency plan. Create a clear roadmap to help you achieve your desired end state on the cloud. Visualize the entire migration effort timeline and reduce cost and risk, and keep your workforce focused on business innovation and change management. Now that you know what to look at before moving to the cloud, let's take a look at what you can do once your environment is on the cloud to ensure that it's up to AWS best practice. Introducing the AWS Well-Architected Review. The AWS Well-Architected framework is based on 5 pillars, which will help you understand the pros and cons of decisions you make while building systems on AWS. By using the framework, you will learn architectural best practices for designing and operating reliable, secure, efficient, and cost-effective systems in the cloud. It provides a way for you to constantly measure your architectures against best practices and identify areas for improvement. The process for reviewing an architecture is a constructive conversation between you and the Silicon Overdrive Well-Architected Review team of AWS engineers, and is not an audit mechanism. We believe that having well-architected systems greatly increases the likelihood of business success. Silicon Overdrive has years of experience architecting solutions across a wide variety of business verticals and use cases. The WAR was developed to help cloud architects build secure, high-performing, resilient, and efficient infrastructure for their applications. The well-architected framework identifies a set of general design principles to facilitate good design in the cloud. It allows you to stop guessing your capacity needs. You can eliminate guessing about your infrastructure capacity needs. When you make a capacity decision before you deploy a system, you might end up sitting on expensive idle resources or dealing with performance implications of limited capacity. With cloud computing, these problems can go away. You can use as much or as little capacity as you need and scale up or down automatically. You can test systems at production scale. In the cloud, you can create a production scale test environment on demand, complete your testing, and then decommission the resources. Because you only pay for the test environment when it's running, you can simulate your live environment for a fraction of the cost of testing on-premise. Automate to make architectural experimentation easier. Automation allows you to create and replicate your systems at low cost and avoid the expense of manual effort. You can track changes to your automation, audit the impact, and revert to previous parameters when necessary. Allow for evolutionary architectures. In a traditional environment, architectural decisions are often implemented as static one-time events, with a few major variations of a system during its lifetime. As a business and its context continues to change, these initial decisions might hinder the system's ability to deliver changing business requirements. In the cloud, the capability to automate and test on demand lowers the risk of impact from design changes. This allows systems to evolve over time so that businesses can take advantage of innovations such as standard practice. Drive architectures using data. In the cloud, you can collect data on how your architectural choices affect the behavior of your workload. This lets you make fact-based decisions on how to improve your workload. Your cloud infrastructure is code, so you can use that data to inform your architecture choices and improvements over time. And improve through game days. Test how your architecture and processes perform by regularly scheduling game days to simulate events in production. This will help you understand where improvements can be made and can help develop organizational experience in dealing with events. Let's take a deeper look at the 5 pillars. The first is operational excellence. The operational excellence pillar focuses on running and monitoring systems to deliver business value and continually improving processes and procedures. Key topics include managing and automating changes, responding to events, and defining standards to successfully manage daily operations. Within the operational excellence pillar, and within all of the pillars, we specifically look at design principles. So within operational excellence, the design principles we're looking at are performance operations as code. In the cloud, you can apply the same engineering discipline that you use for application code to your entire environment. You can define your entire workload as code and update it with code. You can implement your operation procedures as code and automate their execution by triggering them in response to events. By performing operations as code, you limit human error and enable consistent response to events. Annotate documentation. In an on-premise environment, documentation is created by hand, used by people, and is hard to keep in sync with the pace of change. In the cloud, you can automate the creation of annotated documentation after every build, or automatically annotate handcrafted documentation. Annotated documentation can be used by people and systems. Use annotations as an input to your operations code. Make frequent, small, reversible changes. Design workloads allow components to be updated regularly. Make changes in small increments that can be reversed if they fail without affecting the customers when possible. Refine operations procedures frequently. As you use operations procedures, look for opportunities to improve them. As you evolve your workload, evolve your procedures appropriately. Set up regular game days to review and validate that all the procedures are effective and that your teams are familiar with them. Anticipate failure. Perform pre-mortem exercises to identify potential sources of failure so that they can be removed or mitigated. Test your failure scenarios and validate your understanding of their impact. Test your response procedures to ensure that they are effective and that teams are familiar with their execution. Again, set up regular game days to test workloads and team responses to simulated events. And the last design principle is to learn from all operational failures. Drive improvement through lessons learned from all operational events and failures. Share what is learned with teams and through the entire organization. When you do a well-architected review, there are some questions we will ask you surrounding each pillar. For the operational excellence pillar, we will ask you, how do you determine what your priorities are? How do you design your workload so that you can understand its state? How do you reduce defects, ease remediation, and improve flow into production? How do you mitigate deployment risks? How do you know that you are ready to support a workload? How do you understand the health of your workload? How do you understand the health of your operations? How do you manage workload and operation events? And how do you evolve operations? The next pillar is the security pillar, which focuses on protecting information and systems. Key topics include confidentiality and integrity of data, identifying and managing who can do what with privilege management, and protecting systems and establishing controls to detect security events. The design principles we look at when it comes to security include implement a strong identity foundation, implement the principle of least privilege and enforce separation of duties with appropriate authorization for each interaction with your AWS resources. Centralize privilege management and reduce or even eliminate reliance on long-term credentials. Enable traceability. Monitor, alert, and audit actions and changes to your environment in real time. Integrate logs and metrics with systems to automatically respond and take action. Apply security at all layers. Rather than just focusing on protection of a single outer layer, apply a defense in-depth approach with other security controls. Apply to all layers like your edge network, your VPCs, your subnets, load balancers, and so on. Automate security best practices. Automated software-based security mechanisms improve your ability to securely scale more rapidly and cost effectively. Create secure architectures, including the implementation of controls that are defined and managed as code in version-controlled templates. Protect data in transit and at rest. Classify your data into sensitivity levels and use mechanisms such as encryption, tokenization, and access control where appropriate. Keep people away from data. Create mechanisms and tools to reduce or eliminate the need for direct access or manual processing of data. This reduces the risk of loss or modification and human error when handling sensitive data. And prepare for security events. Prepare for an incident by having an incident management process that aligns to your organizational requirements. Run incident response simulations and use tools with automation to increase your speed for detection, investigation, and recovery. The questions we will ask you during the security pillar of the well-architected review include: how do you manage credentials and authentication? How do you control human access? How do you control programmatic access? How do you detect and investigate security events? How do you defend against emergent security threats? How do you protect your networks? How do you protect your compute resources? How do you classify your data? How do you protect your data at rest? How do you protect your data in transit? And how do you respond to an incident? Next is the reliability pillar, which focuses on the ability to prevent and quickly recover from failures to meet business and customer demand. Key topics include foundational elements around setup, cross-project requirements, recovery planning, and how we handle change. The design principles in the reliability pillar include test recovery procedures. In an on-premise environment, testing is often conducted to prove the system works in a particular scenario. Testing is not typically used to validate recovery strategies. In the cloud, you can test how your system fails. You can validate your recovery procedures. You can use automation to simulate different failures or create scenarios that led to failures before. This exposes failure pathways that you can test and rectify before a real failure scenario, reducing the risk of components failing that have not been tested before. Automatically recover from failure. By monitoring a system for key performance indicators, you can trigger automation when a threshold is breached. This allows for automatic notification and tracking of failures, and for automated recovery processes that work around or repair the failure. With more sophisticated automation, it is possible to anticipate and remediate failures before they occur. Scale horizontally to increase aggregate system availability. Replace one large resource with multiple small resources to reduce the impact of a single failure on the overall system. Distribute requests across multiple smaller resources to ensure that they don't share a common point of failure. Stop guessing capacity. A common cause of failure in an on-premise system is resource saturation. When the demands placed on a system exceed the capacity of the system, in the cloud, you can monitor demand and system utilization and automate the addition or removal of resources to maintain the optimal level to satisfactory demand without over or under provisioning. Manage change and automation. Changes to your infrastructure should be done using automation. The changes that need to be managed are changes to the actual automation. The questions we'll ask you during the reliability pillar are: how do you manage service limits? How do you manage your network topology? How does your system adapt to changes in demand? How do you monitor your resources? How do you implement change? How do you back up data? How does your system withstand component failures? How do you test resilience? And how do you plan for disaster recovery? Next, we move on to performance efficiency. The performance efficiency pillar focuses on using IT and computing resources efficiently. Key topics include selecting the right resource types and sizes based on workload requirements, monitoring performance, and making informed decisions to maintain efficiency as business needs evolve. The design principles here: first, democratize advanced technologies. Technologies that are difficult to implement can become easier to consume by pushing that knowledge and complexity into the cloud vendor's domain. Rather than having your IT team learn how to host and run a new technology, they can simply consume it as a service. For example, NoSQL databases, media transcoding, and machine learning are all technologies that require expertise that is not evenly dispersed across the technical community. In the cloud, these technologies become services that your team can consume while focusing on product development rather than resource provisioning and management. Go global in minutes. Easily deploy your system in multiple regions around the world with just a few clicks. This allows you to provide lower latency and a better experience for your customers at minimal cost. Use serverless architectures. In the cloud, serverless architectures remove the need for you to run and maintain servers to carry out traditional compute activities. For example, storage services can act as static websites, removing the need for web services. And event services can host your code for you. This not only removes the operational burden of managing these servers, but can also lower transactional costs because these managed services operate at cloud scale. Experiment more often. With virtual and automated resources, you can quickly carry out comparative testing using different types of instances, storage, or configurations. Mechanical sympathy. Use the technology approach that aligns best to what you're trying to achieve. For example, consider data access patterns when selecting database or storage approaches. The questions we will ask you around performance and efficiency include: how do you select the best performing architecture? How do you select your compute solution? How do you select your storage solution and your database solution? How do you configure your networking solution? How do you evolve your workload to take advantage of new releases? How do you monitor your resources to ensure they are performing as expected? And how do you use trade-offs to improve performances? The cost optimization pillar focuses on avoiding unneeded costs. Key topics include understanding and controlling where money is being spent, selecting the most appropriate and right number of resource types, analyzing spend over time, and scaling to meet business needs without overspending. The design principles in cost optimization include: adopt a consumption model. Pay only for the computing resources that you require and increase or decrease usage depending on business requirements. Not by using elaborate forecasting. For example, development and test environments are typically only used for 8 hours a day during the workweek. You can stop these resources when they are not in use for a potential cost savings of 75%. That's 40 hours a week versus 168 hours a week. You can measure overall efficiency. Measure the business output for the workload and the costs associated with delivering it. Use this measure to know the gains you make from increasing output and reducing costs. Stop spending money on data center operations. AWS does the heavy lifting of racking, stacking, and powering servers, so you can focus on your customers and organization projects rather than on IT infrastructure. Analyze and attribute expenditure. The cloud makes it easy to accurately identify the usage and cost of systems, which then allows transparent attribution of IT costs to individual workload owners. This helps measure return on investment and gives workload owners an opportunity to optimize their resources and reduce costs. Use managed and application level services to reduce cost of ownership. In the cloud, managed and application level services remove the operational burden of maintaining servers for tasks such as sending an email or managing databases. As managed services operate at cloud scale, they can offer a lower cost per transaction or service. The questions we will ask during the cost optimization pillar are: how do you govern usage? How do you monitor usage and cost? How do you decommission resources? How do you evaluate cost when you select services? How do you meet cost targets when you select resource type and size? How do you use pricing models to reduce cost? How do you plan for data transfer charges? How do you match supply of your resources with demand? And how do you evaluate new services? Through all of this, remember, you are not alone. Let Silicon Overdrive help you along the way as you build and manage your workloads. With over 25 years in the IT industry, our consultants offer expert advice on how to best utilize information technology to achieve your business objective, save costs, and enhance efficiency and productivity. Our technical assessments and IT audits help you make the best decision for your business. Our teams will evaluate your current environment for opportunities for improvement, standardization, cost optimization, and alignment with best practices and security standards. We offer flexible support options and comprehensive services from network cabling to security and compliance services. As a provider of fully managed IT services, we centrally manage your IT for you. Some of our customers include Old Mutual, Electrum, DPO Paygate, Stryker, American Shutters, and more. Thank you very much for joining me for this webinar today. I certainly hope that you have learned something, that you got some value from this, and we will be here for any questions and answers.